This will be for the con-assignment quadrilateral problems on the coordinate plane. So you are graphing rectangle ABCD in the coordinate plane. The following are three of the vertices of the rectangle. What are the coordinates of point D? All right, let's see. So we have point D right here. All right, and I am going to write the coordinates for C and A and match them up to point D. All right, let's see. The coordinates for C are 3, -5. And then the coordinates for point A are -7, -2. So for point A, -7, -2. All right. And now we can see point D.
Excuse this interruption. Mr. Raimundo.
We can see for point D, this will match the y coordinate for point C. Okay, this axis right here is the y axis. All right, so this point on the y axis is going to be -5. So the y coordinate for point D is going to be -5. Okay, remember the coordinates are in the form x, y. So the y coordinate is -5, and we can see that matches the y coordinate for point D. Now the x coordinate for point D, if we trace it up to the x-axis right here, it's going to match the x coordinate for point A. All right, this is the x-axis right here. And the x coordinate for point A is -7. So that's going to match the x coordinate for point D. So D is -7, -5. Let's enter that in the box. -7, hit tab, -5. Okay, rectangle ABCD is graphed. The following are the vertices of the rectangle for A, B, C, and D. Given these coordinates, what is the length of side CD of this rectangle? Now, the length of side CD, you can use the distance formula, but it's not necessary. Okay? The reason it's not necessary is because when we subtract the y values, 2 minus 2, it's just going to be 0. All right? So when you have x or y coordinates that match and you're calculating length or distance, you can ignore those coordinates. Okay? So just ignore the 2 on both C and D, and we're just going to subtract 4 minus 0. All right, and really you're supposed to take the absolute value in case you subtract in the other direction, because the length or distance is always going to be positive. So of course 4 minus 0 is just 4. And that's it. Okay, even if you subtract the other way, if you do 0 minus 4, once you took the absolute value of -4, it would still be +4. Okay, so regardless of which direction you subtract, you make it positive. And you just ignore, like I said, you just ignore the coordinates that match. You can certainly use this distance formula if you want, but you don't have to. Okay, here they ask, does coordinate P or coordinate Q represent a greater number? All right, let's see. So remember, these coordinates are in the form of x, comma, y. All right. Now the x-axis is how far left, right the point is. All right. So the x-coordinate for this point is going to match the x-coordinate for this point here. You see, if we went through the x-axis, it would be at the same point on the x-axis. So this is 6 right here. That means P is going to equal 6 as well. All right. And now for the y-coordinate, let's see. The y-coordinate is how far up, down. All right, let me erase this x-axis here. The y-coordinate is how far up, down the point is. Remember, the y-axis is the up-down portion. All right. So if I were to go like this, it would hit the y-axis about there. Now this y-coordinate is 2. So point Q is going to be greater than 2. Now if you look at this point right here, this one is at y equals 5. So obviously point Q right here is going to be less than 5. All right. So we don't really need to know that it's greater than Q. We just know that greater than 2. We just know that Q is less than 5. And we said that P equals 6. So Q is definitely going to be less than P. So P is greater than Q. And that's what they ask. Which one is the greater number? That's clearly P.